Today I'll talk about mass flow rate and volumetric flow rate, and then I'll talk about mass flow rate and volumetric flow rate relationship. Now first, what is mass flow rate? The mass flow rate is the rate at which mass flows through a particular cross-sectional area per unit time, and it can be defined mathematically as mass flow rate is nothing but mass per time. So mass, we know that density into volume, and time is that part time, so that is mass flow rate. So now here is volume. Volume is, suppose that fluid is cross this cross-sectional area and travel some length L in particular time. So now what will be the volume? Volume will be cross-sectional area into length. So here that rho into volume, so rho into area into length. So volume is cross-sectional area into length, then by time. So here if we segregate rho and area, so that is rho into area, cross-sectional area, then length per time. So length per time is nothing but velocity. So that is velocity. So now what will be the mass flow rate? Mass flow rate will be nothing but cross-sectional area, density of fluid, and velocity of the fluid. So here the every parameters, every variable is described here. So m dot is the mass flow rate in kg per second. A is the cross-sectional area in meter square. Rho is the density of the fluid in kg per meter cube. V is the fluid velocity in meter per second. Now coming to the one numerical example of mass flow rate. So consider water flowing through a pipe with a cross-sectional area of 0.05 meter square, a density of 1000 kg per meter cube, and a velocity of 2 meter per second. The mass flow rate is calculated as, so we know mass flow rate, that is mass flow rate is nothing but A into rho into V, a rho into V. So A is cross-sectional area, rho is density of the fluid, and V is the velocity. So here A is 0.05, rho is 1000 kg per meter cube, and velocity is 2 meter per second. So ultimately mass flow rate is 100 kg per second. Very easy, I hope. Then volumetric flow rate. The volumetric flow rate is the rate at which fluid volume flows through a particular cross-sectional area per unit of time, and it is expressed as Q is nothing but volume per time. Remember, mass flow rate is mass per time, volumetric flow rate is volume per time. So now again volume is nothing but area into length, and then volumetric flow rate is area into length by time. So area into length by time. So length by time is again velocity. So volumetric flow rate is area into velocity, where Q is the volumetric flow rate at in meter cube per second, means unit of volumetric flow rate is meter cube per second, and A is the cross-sectional area in meter square, V is the fluid velocity in meter per second. So now example. So using the same pipe with a cross-sectional area of 0.05 meter square and a velocity of 2 meter per second, what will be the volumetric flow rate? So volumetric flow rate is area into velocity. So 0.05 is the area, cross-sectional area, and velocity is 2. So 0.05 into 2, so that is 0.1 meter cube per second. Now relation between mass and volumetric flow rate. So we know that mass flow rate is nothing but rho into A into velocity. So here the relationship between mass and volumetric flow rate, so mass flow rate and volumetric flow rate are related through the density of the fluid. So mass flow rate is nothing but density into volumetric flow rate, and we know mass flow rate is nothing but rho into A into V, where A into V is nothing but volumetric flow rate. Now here this is very important. So sometime mass flow rate is given, so we can easily calculate volumetric flow rate just divided by rho, and sometime that volumetric flow rate is given. If we want to calculate mass flow rate, so we have to multiply density with volumetric flow rate. So here given volumetric flow rate Q and the fluid density rho, the mass flow rate can be calculated, and conversely, if the mass flow rate m dot and density rho are known, the volumetric flow rate can be determined. That's it. Thank you.